Hello everyone, I am EN20403638. We are from Sustainable Group 51. Our project for the Introduction to Sustainable Engineering module is Sustainable for Cement in Cement-based Product. In this world, demand for cement is increasing because the uses of cement are increasing every day. Approximately 2.8 billion tons of cement are produced per year. But cement production and use of the cement create many negative impacts to human health and environment. So we choose concrete as a cement-based product according to our sustainable to in introduction to sustainable engineering post module. Okay, let's see the ingredients of concrete. Cement, sand, aggregate, and water are the ingredients of concrete. Water is only renewable ingredient in concrete. Okay, next slides will be continued by our group members. Thank you.
My EN number is EN 20 38 57 50. This table describes the properties of concrete. Before hardening, first property is workability, which means effort required to manipulate a concrete mixture with a minimum of segregation. Second one is setting. It is defined change in the concrete state from plastic state to hardened state. Next one is segregation, which is seriously affecting the quality of the concrete. Last property is hydration. Chemical reaction take place between cement and water is referred as hydration. The principal properties of hardens, which, which are of practical importance, can be listed as high compressive strength, durability, density, and fire resistance. Of these, compressive strength is the most important property of the concrete because it is easy, easily easily obtained. This table shows properties of ingredients such as cement, water, sand, and aggregate, and how to use them in before and after hardening of concrete.
I am Tarundi BGV, EN20386740. This flowchart is showing the production process of cement and concrete. Limestone and clay are the primary raw materials used for the cement production. There are two main processing methods as dry process and wet process. Once after the production of cement, concrete can produce using the cement with sand, water, and aggregate, then gorging, mixing, transporting, placing, compaction, curing, and the hardened concrete can make. There are many instances of using concrete. Concrete is used for laying floors, making roofs, constructing lintels, beam making, concrete bridges construction works, constructing stairs, constructing pillars, dams construction works, and etc. There are some problems with this product. In this stage of extraction of raw materials, there are two main problems: landscape degradation and resource depletion. In the next stage of cement production, there are four main problems such as high cost, high energy use, air pollution, and health issues. In the next stage, the concrete production, there are another four main problems: sound pollution, air pollution, loss of water waste, and traffic congestion. In the last stage, uh, global using, global warming, and can't recycle. According to the cement is the raw materials of concrete. Especially, we can see that there are some problematic situation in the stage of extracting raw materials, cement production, concrete production, and also is using concrete. Due to these problems, we can consider the concrete as a sustainable product. Hence, the problems should solve or should find alternatives for concrete.
I am Ridvan Sirimanna. My EN number EN20413224. In here you can see what are the alternatives available for cement. First one is metakaolin. The comparing to the cement, this amount of heat is needed to manufacture it, and it need less amount of water to produce the alternative to cement, and its involvement to global warming is less. And the second one is GGBS, ground granulated blast furnace slag. With compared to cement, its advantages are less cost of production and less contribution for global warming, and the less contribution for air pollution. And the third one is fly ash. With compared to the cement, its advantages are less contribution for air pollution, and less energy is reduced for production, and cost of production is less, and the less amount of water is needed when used as an alternative, and the less contribution for the global warming. Considering the above advantages of the three alternatives, we propose fly ash as the alternative for cement. And it can be used as a replacement for cement. It has the similar properties, physical properties as well as chemical properties as cement. Its contribution to air pollution and global warming is comparatively low, and it needs less energy to be produced and less water when it is used. And the fly ash is a production in thermal power plants. Comparatively, it is an environmental friendly material, and since it's a waste from thermal power plants, the cost of production is very low.
I'm Malshani RME, EN 20382544. The main reasons to select fly ash as the alternative for cement in cement-based product are its improved the performances of the concrete, cost-effective and environmental friendly. When we are replacing the cement level 45% and 50% by weight, the slump height increased by 38.46% and 53.85%. Not only that, by taking the percentage of fly ash as follows 30, 40 and 50 by weight of cement, the compressive strength, split tensile strength and modulus elasticity of fly ash concrete will be 80 Celsius, 100 Celsius and 120 Celsius. At the same time, there are no any segregation and bleeding with the replacement of cement with fly ash in concrete by 50%, 60% and 70%. The most important advantage of fly ash concrete is the ability to resist alkali aggregation reaction. Also, it reduces permeability and corrosion of reinforced steel. With 10% and 20% replacement of cement with fly ash, the compressive strength was increased. In the hydration of the cement, the state releases calcium oxide with fly ash silicate to form a strong and durable cement helps to improve the properties of compounds of concrete. Finally, by considering the above reasons, we selected fly ash as the alternative for cement. It helps to reduce carbon dioxide emission, provides sustainable design, slows down the ingress of moisture, oxygen, chlorides, carbon dioxide and aggressive chemicals in the concrete. By replacing the cement with fly ash, we reduce the future demand for cement. Thank you.